So we will say area bounded by a curve and some straight lines. Okay, so we will do it like that. Okay, so we have a better sense of the thing. Okay, now, so 4A, the way we do is we want to tell you one of the meaning of integration. So I'm going to bring you through to know the meaning of integration. Okay, now, you have learned this in your high school before. If I give you okay, if I give you a velocity graph, for example, I start with a velocity of 5 meters per second. Then I move with a constant deceleration. So I ask you to find the total distance traveled in the first. For example, I give you a value. Okay. First 3 seconds. How are you going to do? What is the answer? Huh? 13.5. Okay, how do you get 13.5? Okay, why you find the area bounded by the curve? You're finding the area, correct? You're finding this area, am I right? Why this area represent the total distance traveled? Because you want to find this area is trapezium, correct? Yeah, length times breadth. So it's velocity times time. You get distance, am I right? So in this graph, there is a meaning. The area bounded by the curve, there is a meaning. Am I right? So it doesn't mean that every area bounded by the curve, there is a meaning. Correct? Because I know that velocity is the rate of change of displacement. Am I right? Yeah. So that means the area bounded by this curve represent total displacement. So one thing that I learned from here is what? Can you tell me one thing that you learned? Don't use under, please. What curve? In this case? Is represent this total displacement, correct? So if I want to put in a general form, how can I put it? General statement. If I want to put a general statement, not only in this case, I want to as a general. So just now he put the specific case. The area bounded by the velocity curve and t equal to 0, t equal to, these are called the straight line. Okay, straight lines, t equal to 0, t equal to 3, and the t-axis represent the total displacement. So now, how can I transfer this into a general statement? What is the relationship between velocity and displacement? Okay, velocity is the rate of change of displacement. So that is the key here. So if you want to convert it into a general statement, it will be like that. Area bounded by the rate of change of a function that is, we say f prime x. Within a certain interval of x, and the x-axis is the total amount of what? Total amount of what? Total amount of what? No, I'm not talking about displacement here. I'm talking about a general statement. Total amount of fx. You see, this is the concept. So very important. That's why we need to learn how to find the area bounded by the curve. So this is the first concept that I want to bring to you. So now, are you okay? And this one, for this one, I can find the area easily. Why? For this case, I can find the area easily because it's a straight line. There is a regular shape. I can find the shape, am I right? So if not, then how am I going to do it? Why integration? Why integration? Have you ever asked your teacher why I want to find the area bounded by the curve? I must do integration. Are you sure? Then why should I if I want, okay. So what is, then you tell me what is the relationship between integration and differentiation then? One is forward, one is backward. Okay, I'm not doing driving, okay? Drive forward, drive backward. I'm doing maths. Oh, we don't use reverse. I'm not reversing my car. What's the? Yes. Find the function for rate of change. So I'm talking about what is the relationship between differentiation and integration. We don't say opposite. Opposite, that means I'm standing here, you are standing there, I'm opposite of you. Interval of x. Yes, faster. If I ask a small kids, I say, what is the relationship between plus and minus? How can you tell me equal to 0? What is the relationship between plus and minus? If I tell you 5 plus 3 equal to 8, can you tell me what is 8 minus 3? I don't have to calculate. I straight away can tell you 5. Why?
Because of the opposite side of equal sign, you can interchange.
You see, you all keep saying opposite sign, opposite sign, opposite. We don't use that word opposite. That's why you must speak the max lingo. I don't understand young people lingo. Okay, never mind. But I understand max language. They are not equal. Not. If you say inversely proportional, it will be like that. 1 over. Just on whatever you say, correct? You just cut off one word, then can already. So which word you want to cut? Inverse or proportional? You cut off proportional. Yes, it's the inverse operation. It's the inverse operation. Correct? So that is what you mean. Okay, so that is, so now, why I want to find the area bounded by the curve, I have to use integration. So I'm going to give you a curve. Did you download the one that I give in the Times? Hello? So I told you already, from today onward, we are supposed to use area bounded by the curve. Hello? Hello? Why you every day sit like that and with your eyes closed? May I know why? Did you download that? Under chapter 4, example of yeah. So now, yeah, and the other one, I need the other one. Okay, hold on. Estimation of area bounded by the curve. The first one. Did you download the first one? Estimation of the area bounded by the curve. Okay, so I have explained the first part. So we want to go into estimation of area bounded by the curve. Why I say estimation, okay? Estimation of area bounded by a curve. Okay, so I got give you the example in the text is, I give you a velocity graph, and the velocity function is equal to 2e to the power negative t plus 2. Am I right? You have that? Okay. So now, if I want you to find, okay, estimate I want you to estimate the total distance traveled by the object in the first 4 seconds. Okay, first 4 seconds. So you know here highest is 4. So that means I have to, okay, I'm going to tell you if I want to estimate this, okay, I have to estimate the area bounded by the VT curve so this is the first boundary. Straight lines t equal to 0. This is the second one. T equal to 4. This is the third one. And the t axis. And this is the fourth one. So you see there are 4 boundaries. 1, 2, 3, 4. So it becomes an enclosed shape. It becomes an enclosed shape. So because this shape, one of the side is a curved shape, correct? So you can't really find the exact area, am I right? So now I ask you to estimate. So how to estimate this area? So anyone, can you suggest to me an estimation? Yes? You split it into 2 shapes. Okay, so now we want to talk about the process of estimation. Can I move to the next page? Okay, can you give me one estimation? A value. You give me a value. Okay, so now we want to do the process of estimation. Okay, I want to do the process of estimation, and this is what so how to estimate? You give me a value. Okay, VT is equal to 2e to the power negative t plus 2. Okay, so now give me an estimation, please. Yes, 8, 10. Okay, how do you get 10? So your friend, give me the estimation of this area, estimation. Equal to 10. Okay, tell me how you get 10. 4 times 4 equal to 4 times 4 equal to 16. How do you get 4? Where do you get the 4? Mm. Okay, 4 from the y-axis and 4 from the x-axis, because here is 4. The curve is here. All right. So you get another, so this height is 4. Here to here is 4 units. So here to here is also 4 units. Correct? So if you take 4 times 4, what are you talking about? You are talking about the shape of the area of a shape of, what is the shape called? Is the area of a square can, but I can also say of a rectangle. Is a square a rectangle? Why not? Why not? All squares are rectangle, but not all rectangles are square. Is my statement correct? A square is a rectangle, is a special kind of rectangle. So I put generally a rectangle. In this case, it is a square, but not all rectangles are square. So that's why I don't want to put square here. I put a rectangle. So now you tell me 16 is the underestimate or overestimate? Correct? In this case, am I right? So I'm doing an overestimate. Okay, anyone got other estimation? Can you give me another estimation? Okay, I want an underestimate. Okay, your friend said 4 times 2.6. Okay, what do you get? 14.4. No, 10.4. 10.4. Okay, 10.4. We are not good at mental calculation. Doesn't matter. Okay, so how do you get this answer? Okay, your x equal to 4. So this is your rectangle. Okay, and this is the curve. Right? So which rectangle are you drawing now? Which rectangle are you drawing? Horizontal rectangle. This one is also called horizontal rectangle. What is the height of the rectangle that you are taking? At which point? At which point? Yes, when x equal to 4, you are drawing this rectangle. Am I right? Yeah. And you know that this point, the coordinate is 4, then 2e to the power negative 4 plus 2. So you get from your calculator the approximate value. Am I right? Hello? Huh? You what? Yeah, your mind is processing. Okay. So that's why you get this value, correct? This value is the approximate value of 2e to the power negative 4 plus 2. Am I right? So you see, the area of the rectangle doesn't cover every part that is area bounded by the curve. Am I right? This one, it cover more. So this one, we call it the 10.4 meter is the underestimate. $8.14 for 2.6. Is it 2.6? No, 2 point. So your this one you just simply take any value. Am I right? Okay, 2 point. 2 point what? 036. Okay, so can you change? So if he take 2.6, okay, it will be higher up here. Understand? So it's still an underestimate. You still can say it's an underestimate. Okay, so the answer is 8 point. So this is a very obvious underestimate. Just how yours is not so obvious. I will show it if you want. I can show it to you. Okay, so this is 8.08. No, 8.12. 342. Yeah lah, 8.12 lah. Am I right? Hello? 14. How to be 14? Oh, 036. Okay, 036. Okay, okay, 14. You are right. I don't have calculator, okay? My calculator lend it to one of your friends. No calculator, my mind cannot work. 8.14. Okay, so this is called the underestimate. Yes? No, up to me. So I can have an underestimate. Just now your underestimate is better. It's closer to the real one. I will tell you the reason why. Do you want to know the reason why? Not the closer, the better. Listen here. You look. Just on the case, I call it an underestimate. Also, the reason is because the curve go like that. So 2.6 is here. Correct? So if I draw a rectangle here, so if I cut this piece to paste over here, this is above the curve, correct? That piece I cut. So there are still certain area that I didn't cover, but the area that I didn't cover is smaller. So that's why I say it's a better estimation. That's all. The logic is that. So in your final exam, correct? Or even in your SAT, I can also say which is a better estimation. I let you estimate. I let you judge. You tell me, you give me the reason. You see, you can draw a graph, then you say there are still a smaller portion that the area of the rectangle doesn't cover. So that is a better approximation. The other one is a bigger area that the rectangle doesn't cover. Are you okay? Okay. So now I'm going to lead you from this style estimation. This is a rough estimation. From this style estimation to make our estimation become more and more accurate, closer to the real one until you get everything. Graphic calculator. Okay, so we are going to do that. So key the function into the graphic calculator. Key in y1 as 2e to the power of negative x plus 2. Done? Okay, good. Key in already, huh? Okay, now. Okay, you draw this graph. Okay, for t between 0 and 4, divide into two rectangles of equal width. Divide into two rectangles of equal width. So we can forget about the paper first, huh? That one you can go and read it by yourself. Two rectangles of equal width. Okay, what does that mean? Huh? So listen here carefully. Huh? The first one I will teach you, then the next one you have to do it by yourself. Okay, so first of all, why I have to mention equal width? Okay, there is a reason. Afterward, I will let you know, or you go and find out why it must be equal width. Huh? Okay, what do you mean by equal width? So if equal width, so I have to find the width first. Find the width. So how to find the width? What is the interval of time? So that is the interval that, okay. So you have to get the width of the interval first. Okay, the width of the interval is 4 minus 0. So width, width of the rectangle. Divide by, how many rectangles I'm going to divide to? 2. So put the 2 here. So the width is 2 units. In this case, it's 2 seconds. Okay, so from 0 to 4, I mark down 2 here. So you see the width of each one is 2. So when we say width, we talk about the horizontal of a rectangle. So the rectangle is going to be a vertical rectangle. So this one, the width is also 2 units. So that is called equal width. Okay. Then from here, I want you to make, oh, I shouldn't say make lah, huh? Next, we don't make, or not like making cake. Find the over estimation of the area bounded by VT straight lines, t equal to 0, t equal to 4, and the t-axis. Or I can even, in short, I say find the total distance traveled by the object in the first 4 seconds for this case. Okay, so now how are we going to estimate? So now we are going to say overestimate. So we are going to draw rectangles. Okay, now the first rectangle, you got 2 vertical sides. One is here, the other one is here. Am I right? So which one must I take if I want to take a bigger rectangle? The taller side or the taller side or the shorter side? Taller side. So the first rectangle will look like this. So the height of this rectangle will be y1, 0. Clear? Okay, the second rectangle. I have the left side and the right side, which one is taller? The left one or the right one? In this case, it's the left one, correct? The second rectangle. So this is called overestimate. Correct? So the height of the second rectangle, you will take this point. That is your y2, y1, when the x is equal to 2. Am I right? So if I sum up these two rectangles, area of these two rectangles, will it be more than 16 or less than 16? Definitely less than 16, am I right? Because we didn't include this part. Am I right? So am I making a better approximation now? Yes. So can you find the area of these two rectangles? Okay, so my overestimate will be sum of the two rectangles, the area, sum of the area of the two rectangles. So since they are equal width, so can I put the width outside? So can I say the width times by the sum of the height? Can I say that? Hello, Jeremy cannot see because I write in green. So sum of the area of the two rectangles. You write down for yourself. So equal to the width times by the height of the two rectangles, correct? So what are the heights of the two rectangles? Y10 and Y1. 1 or 2? 2. So I expect this answer to be less than 16. Correct? Okay. So now I make another better approximation. So take out your calculator and count. You have your Y1 there already, correct? So you just take 2 Y1 0 plus Y1 2. Then equal. I don't want to see all the decimal. You know how to call out your Y1, correct? I'm going around to check now. Okay, 12.54. Do you get that? You see? Graphic calculator. So you get 12.52. Where's my pen? Okay, 12.52. So now is a better approximation. 54. Okay, 54. Sorry. Are you okay? Hello? So now, how can I improve my approximation further? How can I improve my approximation further? Okay, then you make a statement. Okay, make a statement. How to improve? How to make the overestimate closer? Or any other case, huh? Okay, tell me how to improve. Hurry up, hurry up. 2 right angle triangles. If I just want to stay to the rectangle, then how to improve? Increase the number of rectangles. Okay, you say increase the number of rectangles, huh? So you use the statement increase the number of rectangles. Okay, example, I increase to 6. 6, huh? Okay, you see how I draw, huh? So you say 6 rectangle, huh? I follow your instruction. Okay, that is my understanding. 1 rectangle, oh, sorry. So you see, I draw 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles, 5 rectangles, 6 rectangles. Can. So what is your problem here? So you have to say, increase the number of rectangles of equal width. So this is very important. If you don't say equal width, up to me to draw lah. Then does it give you a better approximation? Definitely not. But if here, yeah, then I have to add some more. I have to. So this is the accurate one. Increase the number of rectangles of equal width for t between 0 and 4. If you didn't specify this, your whole estimation of improvement is wrong. Are you clear? Are you okay? So that is how. So now I'm going to bring you to integration. Okay, now. Yeah? So shall we? Okay, I have only 2 minutes. Okay, so we will continue afterward. So S N is the number of rectangles. Okay, I put down first. I put down what is N first. N is the number of rectangles. I'm writing a general statement already of equal width. Okay, as N tends toward infinity, what happened to the width of the rectangles? Well, tends toward 0. So therefore, the sum of the area of all rectangles will be, we sum up, correct? N equal to 0, N equal to 1, sum up all. Okay, so all the area. So is the width times by, oh sorry, I should put the width outside. Is the width times by the sum of Fx from I equal to 1 to I equal to infinity. Correct? So in this case, so the width is the delta x. So this one, the sum, we change it to integration. This is the curve, y equal to fx. So from a limit a to b. Yep. So it will be fx dx. So sum to infinity. So this is sum up all the small rectangle. So this integration sign give you the meaning of sum. Are you clear? Okay. So you will get the exact value. So that is how you approach y integration from a limit to another limit, show the area bounded by the curve. So how do we interpret whenever people give you this? We will say it is the area bounded by the curve of y equal to fx, straight line x equal to a, x equal to b, and the x-axis. Clear? Never ever say area under the curve. Got it? So first meaning of integration is summation. Okay, done. So we will do the rest later. Okay, in your next lesson. Thank you.